This is problem number 2 from assessment number 2. It says find the domain and range of the following function. And they give us a rational function, f of t equals 2 over 8 minus t. Now for the rational functions, what you want to do is you want to set the denominator basically equal to 0 or not equal to 0, whichever you prefer. And you're searching for the value in your domain that doesn't work, because you know you have a fraction you can't divide by 0. So we want to figure out when or what value of t will make the bottom 0. Now for this one it looks pretty easy, but we can still set it equal to 0. So let's see. Domain, we're going to say 8 minus t cannot equal 0. So we're going to subtract the 8, and we get negative t cannot equal negative 8. We're going to divide by negative 1 on each side. So t cannot equal 8. So that means my domain can be any number except for 8. So that means the domain of this function is negative infinity to 8, but not including 8, union 8 to infinity. The range of the function then, we're going to find the range of the function essentially by, you can either plug in numbers into this rational function, so numbers that are just to the right of 8 and just to the left of 8, and then numbers that are large on either side to kind of find the domain, to find the range. Or you can look at an asymptote, and I'm actually going to show you both ways. So the first thing I'm going to do is I'm going to plug in f of something close to 8. So I'm going to plug in 8.01, and then I'm going to plug in f of 8.0001. And then I'm going to plug in f of, just on this other side, 7.99, and then f of 7.9999. And then I'm going to plug in a large number, so let's do f of 10,000. And let's do f of negative 10,000 for the small number. So with the calculator, I'm going to take, and I'm going to use the store key. So I'm going to store 8.01 as x, and then type in the function, use the fraction, and we'll say 2 over 8 minus x, hit enter. Gives you negative 200 for 8.01. Now I'm going to use 8.0001, store it as x, grab that function again. Now I get negative 20,000. So you can see that I am approaching, as I get closer and closer to 8 from the right, I'm going from negative 200 to negative 2,000. I keep extending this out. I'm going to approach negative infinity. So part of our range value is going to be negative infinity. Now I'm going to do 7.99, and I'm going to store it as x. Go up and grab the function again. I get 200 for that one. Positive though. Now I'm going to do 7.9999. And I'm going to store that as, store down here as x. Grab that function. That's 20,000. So again, I went from 200 to 20,000 as I got close to 8 from the left. I'm approaching infinity, so infinity is probably going to be a part of this domain, or this range as well. Now I'm going to use 10,000. So 10,000, store it as x. Very small number. So as I plug in 10,000, I got a really small number. That's going to approach 0 from the left. So I know 0 is going to be a part of this side of my range. but it's not going to get to 0. Do the same thing for negative 10,000. Store it as x. Again, I get a really small number, so I'm approaching 0 from this side. So my range is going to go from negative infinity to 0, and then 0 to infinity for this rational function. Now, I can look at this also using a horizontal asymptote. So the horizontal asymptote for this function, the degree on top is 0, the degree on the bottom is 1. So because the bottom it's basically bottom heavy, because it's bottom heavy, the rules for a horizontal asymptote tell you that you automatically have a horizontal asymptote at y equals 0. What does that mean? That means that our function, right, for the most part, is not going to touch that 0 part. It could. There are some functions where it does kind of cross over and then just kind of ride along the horizontal asymptote. But this gives you a good idea of where you might have a range value that doesn't work. And you can see in this problem it does make sense how we can figure it out.